There are three lines that can be drawn inside a triangle. The first one we're going to look at is called the altitude, and the altitude is the same as what we normally call the height of the triangle. So the altitude goes from the vertex to the opposite side at a 90-degree angle. The second line in the triangle we're going to look at is called the right bisector. This line divides the side, or line segment, in half at a 90-degree angle. And a right bisector is also called a perpendicular bisector. That can divide any line segment. It doesn't have to be in a triangle, but specifically because we are looking at triangles, it does divide one of the sides into two equal parts at a 90-degree angle. The third one we're going to look at is called the median, and the median joins the vertex of a triangle to the midpoint of that opposite side. So in a triangle, because we have three sides, I've drawn these three: altitude, perpendicular bisector, and median to the bottom side of the triangle, but we can always turn and rotate any triangle. So that means that for all of these triangles, there are actually three altitudes, three medians, and three right bisectors. You can draw them from any side. So what we want to do is we want to determine the equation of the lines, and we're going to need two pieces of information. So for each of these three different lines in the triangles, we're going to look at whether we need the midpoint, the vertex, or a perpendicular slope in order to find their equations. Okay? With an altitude, we have two things that are happening. We know that it goes through the vertex, which means that I'm going to need the coordinates of that vertex, and it does it at a 90-degree angle, which means I need the perpendicular slope. Okay, so those are the two things we're going to need to find the altitude, the vertex, and the perpendicular slope. For a right bisector or perpendicular bisector, we're going to need the angle, which is 90 degrees, which means again we need perpendicular slope. And we know that it passes through the midpoint, so I'm going to need the coordinates of that midpoint as well. Okay, so this time for the perpendicular bisector, the things we need are the midpoint and the perpendicular slope. We don't need the coordinates of that opposite vertex anymore. Okay, and then so similarly for the median, the two pieces of information we need are, you can see them right from the diagram, the vertex coordinates as well as the midpoint coordinates. If you look at it, it means that we don't have slope, but if I have coordinates of 2 points, I can calculate the slope. So if I just need these two coordinates, the vertex and the midpoint, I can find the equation of the median. Okay? So what we're going to do is we're going to look at an example. So I'm going to give you a triangle ABC. It has vertices A, which are 3 and 4, B, which are -5 and 2, and C, which are 1 and -4. So I'm going to determine the equation of those three lines in the triangle. But before I do that, I'm going to draw out what that triangle looks like. So on a piece of graph paper, we're going to put a grid where I'm going to put in those three coordinates. So I have A, B, and C on the grid. And as you can see, if I connect those points together, that's going to create a triangle. Okay, so we're going to refer back to this triangle, but for the purpose of the slide, I'm going to show you the triangle here, and then you can look back at it if you need to. So in this triangle ABC, we're going to find an equation of one of each of the types of lines. So the first one we're going to look at is the median. We're going to go from point A to side BC. So if you remember a median, it goes through the vertex to the midpoint of side BC. So we said that there are two things, that we need. We're going to need the coordinate of the vertex, and then we're also going to need the midpoint. So since we don't have that, the first thing I'm going to do is I'm going to try to find that midpoint, the midpoint of BC. That's going to be my step one. Okay, so going back to what we've learned about midpoint, this is our midpoint formula for BC. And taking the coordinates from the previous slide, I'm going to add in those coordinates into our equation. So -5 plus 1 all over 2 to find the value of x, and 2 minus 4 divided by 2 to find the value of y. And if I add those numbers together, -5 plus 1 is -4. 2 minus 4, that's going to give me -2 over 2. And I'm just going to simplify those fractions so that the midpoint of BC is -2 and -1. So if you want to go back to your graph, you can take a look at it and see that that should actually be the midpoint. You should be able to clearly see if I graphed it onto the triangle that we drew. And now I have two coordinates. So I have a coordinate for A and a coordinate for the midpoint. We said the median is going to connect those two. So if I want to find the equation of that median, I'm going to need a slope and I'm going to need a y-intercept. Okay? So the first thing I'm going to look for is I'm going to look for slope. Because I have two coordinates, I have a coordinate of the midpoint, which is -2 and -1. That's what we just calculated. And I have a coordinate of point A, which is our vertex at 3 and 4. That was given to us. That means that I should be able to calculate slope. So we need to go back to our slope formula. Okay, so that's the slope from the midpoint to point A. So if I put in those coordinates, I have 4 minus -1 and 3 minus -2. So of course that means adding. So 4 plus 1 is 5, 3 plus 2 is 5, and 5 over 5, that's going to give me a slope of +1. Okay, so we said that in order to find an equation we need two things. We need the slope, but we also need the y-intercept for that median. So that's going to be our third step. We're going to calculate a y-intercept, and we need to use a coordinate. And since we know that both of these points, point A as well as the midpoint of BC, are both points on the line of the median, we can use either of those coordinates. So you can choose which one, doesn't matter which one, but we do need to use the new slope that we calculated for the midpoint to point A, which is 1. And I'm going to put those two values into the y equals mx plus b. That's our general form of a line. Right? So I chose point A that I'm going to use as my coordinate. Like I said, it doesn't matter. You can also do it with the midpoint. If you'd like, you can try that and see if you get the same answer. Okay, so if I put those coordinates and the slope into the equation, I have 4 equals 1, which is our slope, 3, which is the x-coordinate of A, plus b. Okay, so I'm just substituting into our equation y equals mx plus b. And now I need to solve for b. Okay, so if I multiply 3 times 1, that's obviously 3. I'm going to subtract it from both sides to bring it to the other side. And that's going to give me 4 minus 3, which is 1. So now I have a slope and a y-intercept for my median. And that means my final step is I need to just write an equation. So I can just say that therefore the equation for the median from A to BC is going to be y equals x plus 1. It's 1x, but I don't need to write the 1. That's okay. The next one we're going to look at is our altitude. And the altitude, we're going to take it from our vertex B, and it's going to intersect our side AC. And again, if you remember the altitude, it does so at a 90-degree angle. Okay, so in this example, the altitude doesn't go through a midpoint, so we don't need to calculate those coordinates. That's unnecessary. We do need a slope for our altitude. So because we don't have two coordinates for our slope like we did last time, we can't just use our slope formula. We have to go with what we know about perpendicular slopes. So because I know that the slope is perpendicular to AC, I do know things about perpendicular slopes. So let's start with the slope of AC. That's going to be our first step. Okay. In order to calculate the slope of AC, that means I'm obviously going to need the coordinates of A and C. So A was 3 and 4, and C was 1 and -4. That's from our question. And I'm going to go back to my slope formula. If I put in those coordinates, y2 is -4 minus 4, and x2 is 1 minus 3. So that's going to give me -8 over -2. And again, I can just simplify that. That's a fraction. 2 negatives make it +4. So this is my slope of AC, but what we said is we don't actually want the slope of AC. I want a slope of an altitude, which is then the perpendicular slope. So if you remember from before, perpendicular slope means that I'm going to take the slope of AC and I'm going to make it into the negative reciprocal. So because the slope is +4, the negative of that would be negative, and reciprocal would then be 1 over 4. So there's no calculation, I just have to remember that perpendicular slope means I need to take the negative reciprocal of the slope, and now I don't need that slope of AC anymore because we're looking for an altitude. Okay, so we said to find an equation of a line, we need two parts. We need the slope and the y-intercept. So now I have a slope of my altitude. what I need now is the y-intercept of my altitude. Right? So we're going to go back to our equation y equals mx plus b. We're going to find the y-intercept. So I have my perpendicular slope, that's the slope of the altitude, and I have a coordinate. I know that it has to go through the vertex, which is b. So that means I need to go back and get the coordinates of vertex b, which is -5 and 2. And again, like I said, we're going to use our perpendicular slope and substitute all these values into our y equals mx plus b equation. Okay. So I'm going to substitute in our values. Our y is +2. Slope is -1/4, and x is -5. So if I substitute in those values, I'm going to get this equation. 2 equals -1/4 times -5 plus b. So we're using some fractions. That's going to be a little bit more complicated, but we do know how to work with fractions. When I multiply fractions, 2 negatives will make it positive, and then 5 times 1/4 is just going to give me 5/4. Okay, so I'm going to multiply first. Now I have this 5/4. I need to move it to the other side to isolate b. So I'm going to subtract my fraction. So I have 2 minus 5/4. And that's equal to b. And now for me to subtract fractions, I'll need a common denominator, right? So that means I'm going to make my common denominator 4, which means now that's going to become 8/4 minus 5/4. So that's my common denominator. And 8 minus 5, that's going to give me 3/4. That's my value of b. Okay? So now I have an altitude with a slope of -1/4 and a y-intercept of 3/4, which means I can write my equation. Okay? So I'm going to write my equation, therefore the altitude from b to AC is y equals -1/4x plus 3/4. Okay, so the last one that we're going to look at is the right bisector of AB. So right bisector, we said right bisectors actually can intersect any line, but specifically in a triangle. It goes through the midpoint of the side at a 90-degree angle, right? So similar to our first example, because it goes through the midpoint, that means I will need the coordinates of the midpoint of AB. So we're going to go back to our midpoint formula, and our coordinates of AB are 3, 4, and -5/2. So I'm going to put those values into our midpoint formula. 3 plus -5/2 and 4 plus 2/2. If I add those together, that's going to give me -2/2 and 6/2, which we can reduce to -1 and +3. So again, if you look back at your graph and you put in this coordinate, you should be able to see that that actually is the midpoint of AB. So we said that, again, now I want to find the equation of a right bisector. So to find an equation of a line, we need two things. We need slope, we need y-intercept. Right? So again, for slope, we only have one coordinate. This right bisector may or may not go through the vertex. We don't know. So I can't use the vertex that's diagonal across from it. The only point that I know that it goes through is that midpoint. So in this example, again, I can't calculate the slope, but what I can do is I know that it crosses through at a perpendicular angle. So again, I can calculate instead the slope of side AB. Okay, so we have our coordinates up at the top again. I'm going to use my slope formula. So y2 is 2 minus 4 over x2, which is -5 minus 3. So if I subtract those numbers, 2 minus 4 is -2 over -8. And again, I can reduce that. That's going to give me two negatives, which is positive. The slope is going to be +1/4. Okay, so again, this is the slope of AB. That's not the slope that I need. In order to calculate the equation of the right bisector, I need the perpendicular slope of AB. So again, what we're going to do is we're going to take the negative reciprocal of that slope. So the slope of AB was 1/4, which means that the negative reciprocal should be -4. Okay, so this is my perpendicular slope, which means this is the slope of the right bisector. That's the one we're going to use for our equation. And again, now I need to find a y-intercept. Right, so we had two parts to our equation, the slope and the y-intercept. The second part, we need a coordinate. So we said the only coordinate that we know that the right bisector will intersect is the midpoint. So I'm going to have to use that midpoint to find the y-intercept, as well as our perpendicular slope that we just found. So we're going to go back to our equation, y equals mx plus b, and I'm going to substitute my perpendicular slope, which was -4, as well as my midpoint, which is -1 and 3. So if I put those values into my equation, I should end up with 3 equals -4 times -1 plus b. Again, we multiply first, so -4 times -1, that's going to give me +4. And then when I move the 4, I want to bring it to the left side, so that means I'm going to subtract 4 from both sides. 3 minus 4 equals b, and then 3 minus 4, that's going to give me a -1. Okay. So now we have our perpendicular slope, which is the slope of our right bisector, and our y-intercept, which is -1, and our final step now, again, is to write our equation of the right bisector. Okay, so in order to do that, we're just going to put those two pieces together, and the equation of the right bisector of AB is going to be y equals -4x minus 1.